Hello everyone. Today we shall discuss about lines and angles of chapter 5. Here we already know about the definitions of lines, line segments and angles, right? Here you can identify again what is a line segment or a ray. Actually there are three definitions. One is line segment, one is line segment, right? One is line segment. Line segment is what? Recall that a line segment has two endpoints. Here, suppose this is a line segment. It has two endpoints, that is A and B, right? If we extend the two endpoints in either direction endlessly, we get a line. Suppose this line can be extended. That means if we give an arrow, it is going on and it is also going on. Then you can say that as line, right? And if there is only one endpoint and there is arrow in one direction only, this endpoint is fixed and there is arrow in this direction, and this is a ray. This is a ray, right? This is a line and this is a line segment. This is a line segment, right? That means a line segment has a fixed value of length. Length is fixed from here to here, but a line doesn't have a fixed length. Length is infinite. And here also, in case of ray also, there is only one endpoint in ray, but we cannot define the length of the ray, right? Only in case of line segment we can define that this is a line segment and is a fixed value of length. In case of line, it doesn't have a fixed length. In case of ray, it doesn't have a fixed length, right? Now, here you see, given this is a line segment, and 2, this is a line, and number 3, this is a ray, right? And ray has only one endpoint. This O is the one ray. O is the one endpoint, that is, namely, it is starting point, right? Now we shall define other factors, that is angle. Here you see, we again recall that an angle is formed when line or line segments meet. Here you see this is a line segment, three line segment AB, BC and CA. Here the three angles are formed, angle ABC, angle BAC or angle ACB. But in case of lines, here you see two lines intersect at the point O. In this case, there are four angles formed by the line, angle POS, angle ASOQ, angle QOR, angle POR, etc. Like that means we can angle is formed when line or line segments meet, that is, in this case angle is formed. I will define the various related angles. Complementary angles. When the sum of the measures of two angles is 90 degree, the angles are called complementary angles. Are these two angles complementary? 60 plus 30 is 90 degree. Therefore, one angle is complement of another. Here in this case also, one is 35 degree, one is 65 degree. If you add the 65 plus 35, 70, 80, 90, 100, this is not a complementary angles. That means when the sum of the measures of two angles is 90 degree, the angles are called complementary angles. Whenever two angles are complementary, each angle is said to be complement of the other, right? In the above diagram, here you see the 30 degree angle is the complement of the angle, complement of the 60 degree angle, and vice versa you can see also, right? And the next one is supplementary angles. Here you see one is 60 degree and one is 60 degree and one is 120 degree. 120 plus 6 is 180 degree, right? Here also this is 68 degree and this is 112 degree. If we add the degree, 8 plus 2, 10, carry 1, 0, 7, 8, 180 degree, right? That means both these here also 100 plus 80, 180, right? 135 plus 45, 40, 180, right? You notice that the sum of the angles, measures of the angles in each of the above pairs comes out to be 180 degree. Such pairs of angles are called supplementary angles. When two angles are supplementary, each angle is said to be supplement of the other, right? That is supplement. That means when two angles are supplementary, each angle is said to be supplement of the other. That means 100 degree is a supplement of 180 degree and 80 degree is a supplement of the angle 100 degree. Here also 135 degree is a supplement of angle 45 degree and 45 degree is a supplement of angle 135 degree, right? Now adjacent angles. Here there are three characteristics to find the adjacent angles. Here in this case you say at both the vertices, here there is a book. When you open a book, it looks like the above figures A and B. We find a pair of angles, that is this angle and this angle, right? Placed next to each other. At both the vertices A and B, a pair of angles are placed next to each other. These angles are such that they have a common vertex. This vertex is common. This is O or anything you can say. They have a common arm. If we write the various arm, that is if we write this is A, this is B, this is C, and this is D, right? Here you see they have a common vertex. The B vertex is common. B vertex is common in ABC and CBD. B vertex is common in both angles. They have a common arm. Here you see BC is common to this angle ABC and BC is also common to angle CBD, right? The non-common arms on either side of the common arm. This is the common arm. This is non-common arms on either side of the common arm. Such pairs of angles are called adjacent angles. Adjacent angles have a common vertex and a common arm but no common interior points. If you remember that it has no common interior points, right? Such pairs of angles are called adjacent angles. Adjacent angles have a common vertex and a common arm and no common interior points, right? Next, we'll discuss about linear pair. Now we'll discuss about linear pair. Linear pair. A linear pair is a pair of adjacent angles. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Here you say a linear pair is a pair of adjacent angles. Pair of adjacent means side by side. That means it has a common vertex, it is a common arm and no interior points. Whose non-common sides are opposite rays. These are non-common. Is opposite rays here. This ray is opposite to this ray. And here also you say that this is not a linear pair because this ray and this ray is not in opposite direction or opposite rays, right? That means the angles in a linear pair are always supplementary degree, that means 180 degree. Here you see that is angle 1 plus angle 2 is equal to 180 degree, right? Note that a pair of supplementary angles form a linear pair when placed adjacent to each other, right? Note carefully that a pair of supplementary angles form a linear pair when placed adjacent to each other, right? Next one here is C. This is example of linear pair, a vegetable chopping board, right? A pen stand, because this angle plus this angle is 180 degree, this angle plus this angle is 180 degree. Not only that, they have a common vertex and they have a common arm, and the non-common arm are opposite to each other, right? This is the definitions of linear pair. vertically opposite angles. Here you see there are two pencils. Write this. The angle 1 is vertically opposite of angle 3 and angle 2 is vertically opposite of angle 4. And we know that in case of vertically opposite angles, angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Right? This have to remember that the opposite angles are equal. Vertically opposite angles are equal. That is angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Right? You have to remember this one. Now when we conclude that when two lines intersect, the vertically opposite angles so formed are equal. Right? That means angle 2 is equal to angle 4 and angle 3 is equal to angle 1. Right? And here you see angle 1 plus angle 2 is equal to 180 because this is straight line. And angle 2 plus angle 3 is equal to 180 degree. That is a angle 2 is equal to angle 2 is equal to angle 3. Angle 2 plus angle 3 that is also 180 degree. Therefore, we can say angle 1 is equal to angle 3. Right? And similarly, you can prove that angle 2 is equal to angle 4. Here you can prove also that angle 2 is equal to angle 4 and angle 3 is equal to angle 1. Right? You have to remember this also. Now, we have found out the various topic in this chapter. Now we shall discuss in the next video, we shall discuss about the exercises. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.